Okay, we want to apply our sum and difference identities here. So again, pay attention to the pattern. Notice you've got sine, cosine, cosine, sine. That means that we're working with sine, right? And that's going to be either the sum or the difference of these two angles. And you can see that they repeat, right? So if it helps, you can label alpha, beta, alpha, and beta. You don't absolutely have to do that. But remember, we write alpha first, beta second. In this case, because they're adding, it doesn't make a huge difference. But you should technically put them in this order. It will make a difference if you're subtracting. Okay, the idea behind this is we can use our sign identity, right? You can maybe say sine sum identity. I don't expect you to write the whole term because it's a long name. But using that sum identity allows us to clean this up and say, oh, that's sine of 40 plus 20 is 60 degrees, which we know using our left-hand trick. It was a really long middle finger there, sorry. This is 60 degrees, and so sine, you're holding down your index finger, sine is 1, 2, 3, square root 3 over 2. And that's what we mean by an exact value, right? Sometimes this is used in reverse, and maybe because the angle measures are not as easily seen as a sum. So one that's common that I've seen is take sine of 75 degrees, right? And we can write this as sine of 45 degrees plus 30 degrees, or 30 plus 45, same thing, right? And the idea is I go from a value that I don't necessarily know into two values that we do know. Those are common ones that we can use our left hand to figure out. So this one you could expand sine, cosine, cosine, sine, right? And you could actually figure out all these values. This is root 2 over 2 times, this is root 3 over 2, root 2 over 2, and 1/2, right? And we could actually simplify this. I know this isn't the question I asked you, but we could actually simplify this to the square root of 6 over 4 plus square root of 2 over 4, which is just root 6 plus root 2 all over 4. So it could be used in either direction. This set just happened to ask you to condense it as opposed to expand it out. Concept is the same though. Okay, so second round of this question, we are using cosine, you're underlining here, cosine, cosine, sine, 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 right? So that means that this is cosine. Again, we want to identify alpha, beta. That is helpful. So this one's alpha, that one's beta. Again, alpha, beta. And the order is going to make a difference here because remember cosine has the opposite plus or minus sign in the middle. So this is going to be subtracting. So again, subtraction is not commutative. That means the order makes a difference. So you have 7 pi over 12 minus pi over 12. And again, we simplify this. So you have cosine of 6 pi over 12, or better than that, cosine of pi over 2. And again, you could use your left hand. Pi over 2 would be up here. You'd have 0 fingers, so this would be 0. An alternative way to think about that is on your unit circle, right? It's the point up top. Okay? I guess I should have highlighted my finger here. I guess that's your thumb. So, okay? I'll see you in the next group.